Dr. Ranjana Mehta is Associate Professor in the Industrial and Systems Engineering at Texas A&M University and Director of the NeuroErgonomics. She'll be giving a presentation on the work she's been doing to understand, quantify, and predict human performance in high-risk environments. That's kind of what we are. Fatigue has been cited by the CSB in several recent catastrophic events. We're going to see that the presentation that fatigue is not, management is not as simple as giving workers a day off every 14 days.
Thank you so much, Dave and Angela, for inviting me to present on this very important topic. And thank you everyone for being here. From what I've heard in the break before, that this is the second half of your day for this meeting. So you are more likely to relate to the topic at hand, which is operator fatigue. I am Ranjana Mehta. I'm an associate professor in industrial systems engineering at Texas A&M University. And understanding operator performance under extreme conditions of stress and fatigue is something that I have researched for over 12 years right now, and more than 6 years in the process industry. Okay, so I need to just figure out how to move on to the next slide. There you go. I think there is a pretty good emphasis in your work group on considerations of human errors in process safety. Just a reminder that most of the accidental losses, except for some natural disasters, begin with some sort of human error. And this was, an inference that was concluded from data from more than 1,500 investigations. I have been told that you all are doing really good work around understanding the contributions of human factors in system failure, as well as designing better systems. And this is a slide that I took directly from what Dave presented, because I think this is an impactful slide. This is showing that most of the more than 90% of process safety incidents are caused by human error, and yet we continue to measure equipment failure alone and expect the outcome to improve. I think this is the first step in understanding that we are not looking at the right places to make a change, and we need to, recalibrate our steps and figure out where our emphasis for change needs to be. Fatigue is a big issue in the process industry, and in fact, some of the prior events that have been documented very well and investigated by the Chemical Safety Board has implicated fatigue as a causal factor. So this is essentially the Texas City disaster that occurred that killed 15 workers and about 180 that were injured. This is an excerpt that I took directly from the CSB report that talked about the various factors that led to the conclusion that fatigue was a major factor. It said that the day board operator was likely fatigued. They were working 12 hours shift for 29 consecutive days. Not only was this excerpt important in letting us know that fatigue was a contributing or a causal factor in this incident, but it also told us that it wasn't due to the noviceness of an operator, that even experienced operators were the one who were highly fatigued, and that probably led to the incident. So this is something that is really, really important. They cited human factors deficiencies as one of the contributors of this catastrophic accident. The human factors deficiencies were lack of control of worker fatigue, poor human system interface design, poor communication, out-of-date and inaccurate operating procedures, and poor communication between workers at shift handover. The key thing that I took from this excerpt was that the CSB very diligently listed the various human factors that impacted, that contributed towards this accident. However, what is missing from such investigations is the intersection or the interplay of worker fatigue or lack of sleep that the workers had with poor human systems interface design, with poor communication by radio or phone, with operating inaccurate and out-of-date operating procedures. Because there are some, some of these are tools that are used to help that are supposed to help the workers. But if the workers is beyond help to begin with, these tools need to consider that in their original design. And this is how I feel, fatigue can be utilized to help. Fatigue can be, looked into to make such tools more effective. This is another investigation. This is the Macondo well explosion that happened. Now here, CSB wasn't able to implicate fatigue. However, they did emphasize that one of the factors that could potentially have played in was sleep. Workers were on 21-day hitches over here, and they were likely fatigued due to sleep, partial sleep loss. This is important because, when someone tells us, give us a statistic around fatigue and workplace incidents and accidents, that is one thing that is not well documented. And this is a true example of that. CSB did conclude that overall sufficient information is not available for a causal connection to the blowout. Yet the facts outlined here raise sufficient concern for the offshore industry to address fatigue as a safety issue. So I wanted to present this, but I also wanted to present what happens, once someone is in an incident. These are testimonies that have been taken directly from the Deepwater Horizon joint investigation that was done after the Macondo incident. And here you could see that, workers who were interviewed after the fact, they were talking about their experiences. They were talking about how they couldn't count 1, 2, 3 because they were highly stressed. So, the processes that are considered very automatic in an individual is not so anymore under high levels of stress or under high levels of fatigue. People were frozen up, they couldn't move. And so what this tells us is human behavior is very different in a general state versus in a state of high fatigue or high stress. Not only do we not focus on human factors in general based on the information that we have collected so far, we don't consider human behavior in extreme states or contexts of fatigue and stress. This is important because one behaves very differently when one is fatigued versus not. And so it is important for us to look into human behavior or human performances under these conditions if we are to design systems that are supposed to be used in critical scenarios and critical contexts. So, it's not all bad news. We have done a really good job of learning from our mistakes. After the Texas City incident, American Petroleum Institute developed a fatigue risk management system, recommended practice 755. And they did a comprehensive development of this FRMS that should be based from sound science of how people get fatigued and shift work and what are the ways to to alleviate the challenges associated with it. The primary focus of the FRMS was hours of service guidelines, where they sort of provided a table around if you're working 10 straight hours on a day, how many continuous shift days could you do versus in a normal operation versus in an outage. Similarly, if you are working in an a 12-hour shift, these are the number of days that you can work continuously before you definitely need a break. There are some challenges though, because the FRMS covers refineries, petrochemical and chemical operations. It does not apply to locations where employees are housed on site. So a lot of jobs that require workers to transport to different job sites and stay there for a couple of days or for a couple of weeks, this FRMS would not apply to them. There are other challenges with API RP 755, and this is something that I took from a CSB independent review of the FRMS. These are not my conclusions, but the conclusions of CSB, where they felt that the FRMS was not the result of an effective consensus process. There were, issues around the use of shall versus the use of should for essential elements. CSB and the independent review felt that the FRMS placed undue emphasis on soft or personal competence of fatigue control rather than more engineering control for fatigue management. And finally, this is something that we have also looked at, where the hours of service guidelines for API 755 was found to be more permissive and less protective of workers based on current scientific knowledge. In fact, one of my grad students actually went in and scourged the literature to see where, if there have been papers that have been published that show that if you work on 12 continuous days, these are the number of days that you can work consequently for. And she wasn't able to verify working beyond 5 days for 12 hours shift work. And so right now, as of now, the FRMS stands unverified. We do think that the FRMS is a good starting point, right? It is something that was put into place after the Texas City incident. So we have something to begin with. But I think like any engineering program, we want to have continuous improvement. So we want to make sure that the guidelines that we have, safety guidelines that we have for workers, are being continuously audited for their effectiveness. What workers have told us in some of our own investigations that we have done, workers have told us that the burden of managing fatigue has largely been placed on them than on companies. Now, of course, we are challenged by the number of sites that we have interviewed. So this is definitely not what is true for all the workplaces. But we have regularly found that fatigue management strategies, direct workers to find ways to mitigate their fatigue, to find ways to identify their own levels of fatigue and to figure out, whether they need to go get hydrated, whether they need to have better sleep, whether they need to exercise. But I think what needs to happen is we need to take a step back and think about how can we distribute the accountability of fatigue management across all the stakeholders in a company, both from the company perspective as well as from the worker perspective. It is a two-way street. There is a reason why we need to have good FRMs, fatigue risk management systems, but there are challenges to developing a good fatigue management systems because good fatigue risk management systems rely on understanding the risk. In this case, fatigue is a risk. If you think about what fatigue is, and I ask someone, can you tell me what fatigue means to you? It is such an individual experience, right? For someone, it could be a mental fatigue. For someone, it could be physical fatigue. For someone, it could be cognitive fatigue. For someone, it could be because they have not slept well. And so understanding the risk becomes a big issue if we don't do it well. The second is once we sort of understand the concept of the risk, in this case being fatigue, we need to be able to measure fatigue. One of the things that we have tried doing when we meet with our industry partners is ask them, how do they measure fatigue? And we are met with almost no answer because there is no good way to measure fatigue. And in fact, even the ones that we have are not implemented well. So measuring the risk becomes a big problem. So if you don't, metric measurement is so important because that tells us if what we are trying to do is moving in the right way and having good progress. So understanding and measuring are critical components of good fatigue risk management systems. So let's take a step back and think about what fatigue is to process industry. Now, I can talk about a lot of literature that is out there that sort of conceptualizes fatigue with big definitions, such as some in front of you. But I've highlighted what is important across most of these definitions. In one way, fatigue is the capacity and the motivation to perform the task at hand. And if they get degraded as a function of time on task, a person is getting fatigued. Another definition looks at the physiological state of the body from various factors, such as sleep loss, circadian phase that usually occurs due to shift work, or workload, whether they are continuously looking at screens for the whole day, or they are physically lifting boxes out in the warehouse. So fatigue really is a combination of these, different factors. Here, I have highlighted some factors that we have found to be pertinent to process industry. Fatigue is associated with extended wakefulness. So we know that as the hours on duty increase, there is a greater chance of vigilance decrement, of perceived fatigue happening, as well as the number of risks that a person can take. In fact, there are some games that look at your performance on, attention and vigilance with hours of wakefulness. So the amount of time that you're awake. So if at a certain point, if let's say you are awake for about 21 straight hours, your performance would degrade to if you were legally drunk, and you don't want to be in that phase. You want to have cognitive. You want to preserve your cognition so that you are able to make better decisions. You are able to remember things. You are able to communicate well. Fatigue can also happen due to shift work. Circadian phase makes a big difference in our physiological processes that helps in attention, vigilance, as well as in physical tasks such as motor coordination. And I'm not going to go deep into how the circadian rhythms in human change over the course of a day, but studies have shown that our alertness fluctuates over the course of a day. Now, of course, this depends on whether you are chronically, you sleep at night and you work during the day, or you work during night and sleep during the day. So if you change that, your circadian rhythm gets imbalanced and desynchrony happens, and that can change alertness, the level of alertness. And this is probably why, night shift work is associated with more, with less of novel introductions of new processes or techniques, and that is left to more so of in the day shift. Fatigue can also be due to workload, and workload can take a lot of different is due to a lot of different factors, right? So if you look at the back picture over here, these are graphics that usually are seen by, let's say, drillers, onshore or offshore drillers. And they are supposed to monitor a lot of different information that is presented to them on the computer screen. This is high cognitive and high visual fatigue that can really result in fatigue over time. On the other hand, you have folks who are doing a lot of physical labor for straight 12 hours. So the fatigue over here is more muscular and overall global fatigue of the body. Both of these, though, impact how you make decisions, how you feel. Both physical and cognitive fatigue have shown to increase risky behaviors. They have both shown to affect decision making. They have both shown to reduce alertness and in process industry, fatigue is a complex construct. It is not as simple as give them one day break so that they could recover from it. It is much more detailed, much more complex than that. It happens during the course of their shift. It happens after the shift has ended and they are sort of recovering, and it happens over the course of multiple days of their shift. Fatigue is also task dependent in that someone who has, let's say, who's in front of a control room and monitoring displays has a different sort of fatigue manifestation than someone who is out on the shop floor or out on the facility plant floor. It is also industry and process specific. It is a process that results in the impairment of well-being, capacity, both physical and cognitive capacity, comfort, and performance as a result of the work activity. It is not just falling asleep. And we can back that up with several studies we have been doing for the past 5-6 years. All right, so we know that fatigue is important. We know that fatigue can affect how can really be impacted by a lot of different work factors. What does that do to our brain, and why is it important in process safety? Fatigue really impacts how your brain sends signals in order to identify any threat process any threat or take action to any external in front of you. The prefrontal cortex, which is the front part of our brain, is highly sensitive to fatigue due to either work overload or sleep restriction or insufficient rest. It is really the process safety section of your brain, if you may. There are 60–70% higher risk of injuries and accidents with fatigue, and that can be attributed to functions in the prefrontal cortex, which are related to concentration, problem solving, working memory, which is how much information can you store in, within the next 20 seconds in your brain, regulation of emotions and communication. Similar to fatigue, stress is another aspect that can impact performance. I want to give you a correlate of what stress does to our body. We keep talking about, oh, that person choked under pressure. That is what stress could potentially do. Stress shuts off our frontal lobe that is responsible for all of the cognitive actions that we may potentially take. And because of that, our brain is forced to take alternative pathways to do the same task. And more often than not, it fumbles when doing it. So an example I want to give you all is, we don't think twice when we have to, when you take out the key of our house, we put it in the keyhole, and we get into the door. We unlock our door and get in. But if there's a bear behind us, there is more chances that we are going to fumble in this very automatic process. Because what happens is, opening the door is sort of a multi-step process, where the first step is putting in the key in the keyhole in that same orientation, turning it, and then opening the door. So this is a 3-step process. But what happens with stress is that it really fumbles things up. It shuts off. You sort of forget a middle step, and you are then, forced to take an alternative action, which might take longer or which might result in sort of an error being made. So can you think about how this would relate to operators following procedures in a high-risk, stressful environment? That can really change their behavior on a frequent procedure that they follow, or more importantly, an infrequent critical procedure that they follow. Fatigue and stress at an individual level or at an operator level can result in absent-mindedness, decreased awareness of environment around them, lack of attention, underestimation of risk, reduced coordination between tasks, memory lapses, reduced ability to process information quickly, and result in slower reactions. So this is at the individual level. But we do know that a lot of process activity, or a lot of activities in the process industries are at the team level. And fatigue has shown to impact functioning of the team levels as well. In fact, this again on the left is a excerpt from the chemical safety board investigation of the Texas City explosion, where they talked about poor communication, poor or no communication workers at shift handover. So there is likely that worker fatigue and communication together created a risk that was larger than what each of them would create individually. However, we are not able to understand that through accident investigations. But research has shown that fatigue and team communication and coordination are interlinked. Therefore, we need to really look at fatigue and what are the causes of fatigue and prevent them from happening, not just mitigate their potential consequences. Now, I may keep talking about fatigue matters in the process industries, but there are challenges to addressing operator fatigue in the process industry, and we understand that. Probably not as much as folks who actually work in process industries, but we are trying our best as academics. There are barriers in terms of safety culture, what people think of fatigue. One of the factors that leads to this sort of safety culture of overlooking fatigue or minimizing the impact of fatigue. In fact, one person had told me that fatigue is unresolvable. And that made me think, is this a safety culture issue? It's because we don't have evidence or statistics around, around incidents with fatigue. We only have major incidents that we, after the fact, can draw inferences from around and say, you know what, this was due to fatigue. But we don't have any real-time continuous evidence about fatigue. And that is creating a barrier to addressing the safety culture aspect, across a lot of other things, of course. We also need to operationalize fatigue. Is fatigue just due to sleep loss or sleep restrictions and shift work? Or is it due to the sort of work environment that the person is in? Is it due to the human-machine interaction as well? Does the human-machine interaction contribute? So we need to be able to understand and expand our operationalization of fatigue, because if we do, we would have a lot of things to work with and improve to mitigate fatigue from happening. Finally, we do have measuring fatigue as a big barrier. Truly, there is no one way to measure fatigue. Currently, there is no reliable way to look at fatigue in the workplace. Feasibility is something that we need to work on as well. And how sustainable can it be? We have talked to a lot of industry folks who said they started a sleep debt survey, but they stopped using it because they didn't know how to include that in decision making. So it's not just measuring fatigue alone, but they wanted to close the loop with that measurement, and they weren't able to do so properly because there weren't systems that were set. Maybe we researchers haven't done a good job in providing you with a usable system to measure fatigue and then show you how it could be applied back into decision making as well as into your daily operations. Finally, managing fatigue, barriers to managing fatigue are really going back to, are the current fatigue risk management systems evidence-driven? If not, how do we improve them? How do we provide data into the FRMS so the FRMS could really be evidence-driven? And all of this goes back to measuring fatigue, which goes back again to, do we know what we are sort of measuring? And then it goes back to, will we be able to measure it because we have a culture around that accepts that this is a big issue. Now, there are some things that we have done to answer these barriers. Before late last year, we didn't have any major evidence from the field around how fatigue and incident near misses are related. We got a grant from the Ocean Energy Safety Institute, and we were able to collect data from 210 workers working full-time in field positions in the oil and gas extraction or petrochemical processing industries. And with that funding, we were able to showcase that perceptions of fatigue by the workers who completed the survey was significantly associated with both incidents and near misses in the last 1 week. When we found this result, we were so happy because this is one of the first studies that is able to quantify fatigue with incidents and near misses, the language that industry speaks. And we are waiting for this publication to get published so that we could utilize this as a support for our argument that fatigue matters in the process industry. Evidence from the field regarding what fatigue is and how do we operationalize fatigue. We went offshore and we collected data on interview data from workers. And it was interesting that when we asked the questions, we asked them based on how an industry would ask. So about sleep, about shift work, and maybe about workload. But the workers told us that fatigue is yes due to sleep, is yes due to shift work. It is due to cognitive work, it is due to physical work. They were able to disassociate the two. And it is also due to emotional fatigue, emotional factors, being away from home. This is one of the first investigations that we were able to say that the workers identified or operationalized fatigue differently than what the industry does. And to us, this is very encouraging because the workers identify the causes of fatigue. And because they're able to identify the causes, we might be able to manage fatigue by addressing those root causes. We also collected physiological data from workers in an offshore environment to look at fatigue. We used, most clinically valid wearable sensors that were intrinsically safe. For each of these sensors were around $3,000. They were very uncomfortable for workers to wear, but we could get some data, and we found that irrespective of their type of job, there was an increase in 19 to 72%. Of course, it was pretty variable during work that was highly ambulatory. However, what we also found that workers were reliably over their resting heart rate throughout, the 3 weeks that we collected the data from, which means that physiologically, the job during the course of a day really imposed heavy physiological burden on them. We also collected data on, on a game so that we could look at how easy it is to collect, performance-based data on fatigue. We collected this in West Virginia with oil and gas operators. These were truck drivers, of course, and they were doing 12-hour shift driving day versus night. And we found that there were significant increases in lapses, which is you're supposed to act on, but they didn't because of fatigue. And we found that increased over multiple shifts, particularly for night day. So that increased. We then looked at how could potentially fatigue impact workers following procedural tasks. Here, we simulated an offshore environment in a lab-based environment because we wanted to simulate, a failure happening during drilling and tripping. Now, of course, we couldn't do that in the real world. What we found was that when workers are given a time-pressured task, that is, they're told to do it as quickly as they could, and there is a clock ticking, the accuracy on the procedural task was lower under that stress. We also found that even though they performed, seemingly, visibly, they performed similarly between day and night shift, the same procedural tasks had a greater burden on their physiological responses during the night shift than the day shift, which is sort of telling us that maybe just performance on the task itself is not an important metric. We need to look into the worker and see what is the cost on their body for doing that particular task. So there are a lot of challenges with fatigue monitoring. Here I gave you some examples of the different ways in which we sort of were trying to measure fatigue. Physiological responses, while are important, it's crazy it was very difficult for us to collect that data. This whole big data revolution that we have was really not helping. We still have a lot of data unanalyzed because we don't know how to analyze them, because we aren't able to keep up with who went where and from when the data should be collected and all of those things. If we can't do it well as researchers, it would be very difficult for us to tell companies to implement wearable sensors in their environment without providing them with an infrastructure to do so properly. There are compliance with sensors for daily monitoring. There were issues regarding being intrinsically safer. The surveys that we tried to use, we used previous surveys that were developed for, let's say, nurses in healthcare setting. They were long. They used terms like palpitations. Our workers told us, I don't know what palpitations is. So there are a lot of challenges with how other surveys from other industry domains could be utilized in process industry. When we did interviews, the interviews were very helpful, but we know that interviews cannot be a regular way to monitor fatigue in workers in the industry. So there is a need for simple, feasible, sustainable fatigue assessment tool for fatigue monitoring in hazardous environment. We know that, and we are trying to work towards developing one. Because only by doing so, only by collecting these reliable measures, will we be able to guide effective management strategies. There are different ways in which you can assess fatigue. You can do them subjectively. You can have sleep diaries. You can ask them to fill out surveys. You could look at their body using wearables, sleep data, as well as, you could give them an app, a performance test on an app, and then say, hey, why don't you perform this 5-minute task, and that will help me in understanding what's going on with you. However, there are some considerations for any sort of assessment method. They need to be reliable. Are they reliably measuring what they are supposed to measure? What does the data really mean? Are they measuring fatigue, or are they measuring something else? What are the attributes? So if you're asking someone to wear a sensor, is it going to be a wristwatch? Can they wear it when they are, on the job floor? Because I know a lot of places you have to take off your watches and earrings when you are on the job site. Are they sensitive to different levels of fatigue? Everyone fatigues differently. There are folks who are marathon runners and there are folks who are sprint runners. So is our data sensitive enough to assess, changes in fatigue and its implications in, error, human error, with that sort of data or strategy? What are the technology requirements from the company side? Will this fatigue monitoring system require the company to purchase this huge infrastructure that requires, cloud-based services and then requires a dedicated person to do this? Or could it be done using surveys, that are printed out on small booklets? What are some of the organizational factors that could be impacted by these assessment methods? Would it create distrust? Would the workers think that, a big brother is watching me? What about operator trust? Are their behaviors going to change because now they know someone is watching them, so they're going to do things differently? And that would mess up something that you didn't want to mess up in the first place. So there's a lot of different things that need to be considered, for sure. And because of that, my colleagues and I, Dr. Camille Perez, who's also on this call, we created an initiative called FRAME, Fatigue Risk Assessment and Management in High-Risk Environments. We know that fatigue measuring is a big challenge. Fatigue measurement and then understanding the data to actually manage fatigue is also a challenge. So one of the things that there are several things that we are trying to do within this initiative. One is we want to develop good, reliable, and feasible fatigue risk assessment tools. We have developed an app. It's called a Frame Performance app, and it basically tests people's alertness. We've seen some challenges. We actually deployed some of these assessment tools in an offshore environment right now, a couple of weeks ago for 2 weeks. Workers did this twice a day, every day for 2 weeks. And we found that the performance app, there was no way for us to tell two buddies to, hey, do this on the side, don't disturb each other. Their main aim was to do better than their buddy. And so instead of focusing on their tasks, they were focusing on jeopardizing and sabotaging their buddies' responses on the task. So we know that this sort of assessment has some challenges. We created a frame survey. We are in the process of converting that into an app itself. It's a very short survey that we did a lot of work on. It was a participatory effort with Marie Kay O'Connor Process Safety Center, with a lot of process industry folks at the managerial level, at the supervisor level, and at the worker level. And right now the survey stands at, oh my God, I'm going to forget this, but I think it is 18 or 17 questions that can be taken very quickly. And that has high reliability in how people respond to these. We are looking at verifying the current API RP755 hours of service guidelines. So right now we are trying to see if what was out there on the hours of service guidelines, does that hold in an actual work environment? We are looking into how do we look at continuous operator monitoring. We hear these big things on Internet of Things, wearable sensors. We know it's going to come soon to all industries. We just want to make sure that we provide we are able to tell going to design the best sensor that is so non-invasive that it's not going to make any difference, that this is how you need to do it. And this is how the data needs to come out. And this is the sort of information that needs to be fed to the worker or to the supervisor so that they can make the right decision. And for that, we need to make it personalized and we need to predict fatigue. Can you imagine if we had a system that, if you were the scheduler, you were scheduling jobs for the next 2 weeks and you were trying to put man hours to these jobs, and you had sort of like a health and safety dashboard of all your workers, and it would tell you that this person is, in the orange zone and very soon they'll be in the red zone of fatigue. So maybe you don't want to schedule them to more critical tasks. Maybe you want to schedule them to more repetitive, less critical tasks. And then so that's the sort of vision that we have. But we want to do a little bit more because we understand that just developing a dashboard for the sake of operations is not enough. We need to include the human element. The safety culture needs to be included. We want to also, along with the health and safety dashboard, we want to include the health of the safety culture of the company. And we are working on this. Don't ask us how. We are still in year one of figuring out what that visualization might look like. But it would provide, let's say, your supervisor with information on, okay, so I need to schedule this, but I also know that there's going to be pushback. So what can I do? So when your supervisor has some window of understanding of the state of your workers, both fatigue-wise as well as what they're able to accept or not accept, same with your team, they might be able to make better decisions. All right, so I want to end my presentation with a couple of things. I hope you all can join me in saying fatigue matters in this industry. We have overlooked this human aspect for a long time. We need to design systems that take into account how people respond or behave under states of fatigue and not just under any relaxed state. The micro effects of fatigue go unnoticed. We only need one event, and unfortunately more often this one event is a big event that goes on for years. That reminds us, and our indicators are after the fact lagging metrics. Dave had asked me, are there any incidents that have happened after the RP755 were presented? So if a company is utilizing 755, RP755, do they still have fatigue effects? We don't know because we are not measuring fatigue. There is no data for it. So I think that's a challenge. We need to proactively measure worker fatigue because by doing so, our fatigue risk management system approach would be effective because they would provide us with early indicators of errors and even productivity changes. We would be able to schedule jobs and workers to minimize fatigue risk and increase productivity. And this sort of data-driven approach can provide us with, historical data for longer-term strategies of how we want to, move ahead as a company. And finally, I can't emphasize this enough. I do think that industry and researchers like us need to work together. I can do a lot of things in my lab, from fatiguing people to, shocking their brain. I've done that in my lab, but it's not the same learning from a worker and seeing what's happening to them over the course of multiple days. And only if we are able to do that, we would be able to provide you with the right tools that you could utilize sustainably, feasibly, and reliably in your workplace. So folks, this is all that I have. I'd like to thank my lab. They are an amazing group of people. Mary Kay O'Connor Process Safety Center for providing initial funding for this initiative, OESI and the National Academies of Sciences, and all our sponsors and collaborators. Dr. Perez is right here, so I am happy for any questions you may have.
All right, so I'll pick up first the questions that we had posted during your presentation, and there were just two. There were a lot of chatter going on, but essentially two questions. First, if you could go back to the frame slide, which was, I think, your next to the last, or your third from the last slide.
Yes, this one?
Yes, this one. So there was a question of how does your frame tool relate to the safety culture index assessment?
So that's a, so how much time do I have, Angela? Because this is a continuous project. We just started this year. So this is one of our recent project that we got funded by the National Academies, the Gulf Research Program, where we are sort of trying to understand the relationship between safety culture and fatigue in the workplace, so that we can create a dashboard that can provide frontline supervisors with information to make right decisions regarding scheduling, as well as any sort of changes in personnel planning or work planning. So we know that fatigue and safety culture are highly interlinked. we are trying to see if safety culture can, if we understand the health of the culture of an environment, does that help us in designing better fatigue management strategies? So one of the things that we found in our research was we had one offshore worker telling us, I'm fatigued, yes, but I'm not going to go tell this to my supervisor, because then he'll wake up my buddy who's supposed to take over the night shift, and he needs to sleep right now. So that's a good sort of safety culture, but in a way that's, that is highly telling of a lack of resources in the environment. So we want to elucidate that using this dashboard so that the frontline supervisor understands the reason why this person may not come up and say that they are fatigued, and figure out, other ways in which, this frontline supervisor can solve this challenge. Now, to be very honest, I don't know how this dashboard will look like. We are working with industry folks right now and interviewing them and asking them questions about what they would like to see in this dashboard. So if you have any ideas or any suggestions, I'm here to take them.
I think that was a good answer to the question. The other question that came up with, do you have any data that might contrast, let's say, U.S. work culture versus, say, the French concept of shorter work weeks and limiting how long that people drive? Is there any data to support that increased regulation limiting the number of hours people work in certain countries has any relationship to having incidents in the process sector?
That is a spectacular question. I am sure there is a lot of correlates, a lot of inferences we can make just based on the sort of regulations and the safety standards that are put across different regions, global regions, and the incidents and near misses that emerge from those regions. I have talked to a lot of folks from Canada on, ergonomics and safety practices, and they're not shocked, but they wonder, why, despite having so many challenges here with incidents and near misses, why don't we have a more stricter guidance around, safety standards? So yes, there is discrepancy. In fact, a lot of research that we find on worker safety and fatigue in high-risk environments, we actually see them from European regions. It is probably also because companies are interested there in funding those research because they are supposed to address those issues. But beyond that, I won't be able to speak too specifically about that.
Okay. Thank
Hey,
you.
Angela.
You had a question?
Yeah, this is probably a good time to open it up to hand raise, and
Yeah,
Murley
got a question. Well, I had written down just two, so I've gone through those. All right, so Murley, what was your question?
So what we have spoken here is all about fatigue based on hours at work. But how do you factor in high number of tasks to be completed, which can also lead to fatigue? So say, when you have situations like you're recovering from a hurricane, or you're recovering from a backlog of tasks when people come back from a situation like COVID, that leads to stress and fatigue both together. So is there any studies that you've done on things like that?
Yeah, actually workload. So what you are referring to is, increased intensified workload. So the number of tasks that have increased and, the time that are offered to complete those tasks has reduced. And in fact, what that does is that not only increases workload, but it also increases stress due to time pressure. And one of our studies where we looked at procedural tasks with time pressure, we did find that folks who were under pressure to completing the task in a short amount of time were making more errors. And not just that they were making more errors. It was not just performance based. We also saw that it went more into their physiological responses as well, which means that they were now physiologically impacted. That would mean that if they weren't given enough rest after they have completed the task, they wouldn't recover properly, and that would result in fatigue creeps over time.
Ranjana, what's the relationship between fatigue? You mentioned stress here. What about other stressors like heat stress? I had a very large team in West Texas where it was routinely over 110 Fahrenheit, and they were also working these kinds of hours. Do other physical stresses really amp up fatigue?
So heat stress definitely is an environmental factor, as is cold, temperature is an environmental factor that can increase fatigue. So fatigue really is, any task that is continued over a period of time without adequate rest, and without this adequate rest, you see impairments happening. And so heat stress can magnify, manifestation of general fatigue over time. Similar to vibrations can do that. There have been studies that have looked at how whole body vibrations can really amplify alertness and can really impact alertness and vigilance in drivers. And that is why there is so much work done in mitigating these vibration effects or damping these vibrations in trucks, so that doesn't contribute to vigilance and alertness decrements in drivers. So yes, fatigue really is if you think about fatigue, it's a defense mechanism of your body, right? It is telling you to slow down, and you don't want to ignore it, and you don't want it'll happen. If you go on beyond your capabilities, fatigue is bound to happen. The idea is not to say that we don't want fatigue to happen. The idea is to make sure that you understand when it's happening, and you identify the causes of why it is happening so soon. Because a person may potentially be able to work for 10, 12 hours in a safe manner if we can ameliorate or if we can reduce the sort of burdens that are amplifying or accelerating their fatigue during the course of a shift.
Luis, you had a comment, question?
Actually, I have a question.
Okay.
Because number one, thank you very much. This was a great presentation. I mean, I really, really enjoyed it. Thank you very much. But my question is, I was really shocked by what you truly say. Hey, listen, all these are lagging indicators. So what can we do in our community? Let's say that, for example, do we have some kind of methodology, something we can say, oh, if we're going to take more than 2 orders of magnitude credit for this operator action, we should first, before the guy start working, do an analysis of the fatigue, how is his condition, similar to what they do with the pilots, check them up before we say, okay, now we give you the responsibility. This is what you are suggesting?
But I think we need to keep that in mind, right? Because more often than not, we see these major incidents happening, either very early in the morning, or if someone has been, let's say, on their shift for 30 consecutive days. So clearly what is happening is the system, of course, there are a lot of other factors that lead to the incident happening. Fatigue is just one of the factors, but it is an important factor, particularly in the Texas City incident. So you're right. In a way, we are sort of saying, if this is what happens when you do an experiment with someone who is completely fresh, you may want to add some safety factor to it that accounts for a person's fatigue levels. We do that all the time. We in industrial engineering used to do that all the time before the field of human factors came up. We said we are going to put 20% safety factor there to account for human variability. But we can do that more systematically. We don't need to do that in all of the processes. We need to do that in the processes that do matter, right? So if there are processes that have high consequence or are critical in nature, we need to be able to understand how much variability is in how humans behave with this process, and is that variability reliable or not? We do this for equipment all the time. We look at equipment reliability. Why aren't we doing that for for human? Because human is another element in the system. So yes, I think that's where we may potentially want to go, but that requires a huge shift of an approach, which is now we are asking people to change their instruments. And I would have loved to start with that, but that's not going to happen. I know that's not going to happen immediately. But what is going to happen immediately is to show that this is going to impact. Let's collect the data first. And then once we have that data can be given to you all who design these instruments, systems well, right? And you can decide based on that how much of a safety factor you need to put in for which processes. So I hope I've answered that question.
I think you have. You have. Thank you.
Thank you, Luis. In the chat stuff, I've mentioned turnarounds and new project installations a few times. I give the two extremes of workers. You've got the worker in the field who's actually pulling wire, so they're physically getting tired from being outside and going up and down scaffolding and doing the wire pulling. And then you have the engineer who had a marathon to get the system, to get a PLC through FAT, and now they're at site participating in the site acceptance test of that system. They're inside, air conditioning, sitting at a desk. And so there's this perception sometimes that only the person in the field is getting tired because they're hot and they're physically laboring. And so what I see is that there'll be processes in place at the plant to make sure that those guys are getting a break every hour, that they're getting a good lunch. But then the engineer, well, if they're not actively working on a loop, then they're actively supporting something else going on. And so the engineer who isn't physically active is actually getting very mentally tired and stressed because it doesn't let loose. And so on this last project we did, we ended up creating a new policy and we called it Mental Health Day. And if you got to the point where you felt like you weren't being as productive as you should be, or you felt like you were about to be in tears or about to scream at somebody, you could request the next day off as a mental health day. Now, we never had that many requests for mental health days, so we never had anybody push what would be considered reasonable. But it was very interesting how just that one mental health day, I'll put air quotes around it even though you can't see it, that how much better the person felt coming back after just that one day. So it really didn't require multiple days of break, just some break from the stress and anxiety of never being left alone. How does your frame take into account what I just described as two very different environments for creating fatigue?
So, when we decided, so there are a lot of different tools that we are looking at for frame, right? So one is the survey measure. The other is an app on a phone. And then we are doing some continuous monitoring with variables and using AI to predict it. So going back to the survey tool, we developed it in a way to help workers respond. First of all, the workers needed to know what was being asked, right? So, in the chat over here, I was scanning through. A lot of folks have said we have looked at fatigue in the aviation sector, so we just need to translate, which is what we thought too. But really, it's not the same. We understand what fatigue does on a mechanistic level, But when we have to implement fatigue, management strategies or monitoring strategies in a particular industry domain, it's not a simple pick it up from aviation and put it in oil and gas or in petrochemical industries. It requires us to better understand petrochem industries and challenges associated. What we found was that workers couldn't complete the surveys because there were questions that were asked that they didn't understand. So if they're not understanding what we want to ask them, you're not going to get the right answers. Second, the oil and gas, at least the oil and gas industries and petrochem industries, there is a lot of challenges around language as well. So we wanted to make sure that we had, the language, the brevity was designed in a way that it was understood by the workers, and the workers were able to honestly answer without, the perception of the question being asked regarding, are you right for the job? Do you know what? And we also asked the managers and supervisors, do you think asking this question is going to give you some valuable data through which you can help manage fatigue? And they had to answer it. So these were based off of whether the questions were easily understood by workers, whether they would be able to honestly answer it without having the fear of being watched or something. And third, whether the answers on the questions were found to be useful by frontline supervisors and managers. So the frame survey as of now, we haven't tested, Angela, what you were asking, how would it play out? We haven't tested that because we haven't found a right physical test bed or a company to work with. But that's the aim. We want to see how that survey does in different environments. Is it sensitive enough to identify whether one particular intervention is working better than the other intervention? So far, based on how we have designed it, I'm confident that it would, because we have delineated the causes of fatigue. So if the workers answer based on, let's say, if you're telling them to go sleep a day off or rest for a day, the answers would reflect, but we need to test it.
Dave, you have a question?
Ranjana, we had talked when we were developing this presentation, kind of moving some things around. We had a discussion on RP755, and you had mentioned it was a good starting point. But the other side of it is it can be a management out. It can be, as long as I'm following 755, I've taken care of fatigue, check mark. So I'd like to hear from some of the others on whether this is so big a barrier to get past to have management understanding fatigue in a different way than 755. Is the barrier too large for us to get them to support some research or support some additional work in this area? So I'm kind of asking the at-large question on that. Maybe I didn't explain it right.
So Dave, you're asking everyone else and not me, right?
Yes, I'm saying, is 755 a barrier for the industry from management perspective to have this sort of research and this sort of effort to further our understanding of fatigue? Or is 755 enough for management to be complacent with it or compliant with it?
Dave, it wasn't clear. You were asking me or to the rest of the group?
It was to the rest of the group, but it's one of those things that if you're inside a company, it's kind of hard to have a discussion on it. I understand. So maybe I'll just make it a statement.
And I think before that recommended practice was published, there weren't any regular breaks across the U.S. sector. Different companies had different approaches, but pretty much it seemed like if your work was going to take less than 8 weeks, a lot of people just ground through it with very minimal breaks. So I at least see now that the API practice has put a benchmark of what is the maximum amount of time that somebody should really work without a break. But again, it's similar to this morning when we were talking about some things feel very arbitrary. I don't know what the science was behind saying that it was okay to work that many days without a break. And Ranjana's presentation, and I think Camille's will further emphasize that we're really, that time period's a lot longer than the time period that it takes before you start seeing the error rate go up. It's just, we know when you get to that time period, the error rate is entirely, it's like you've run to failure almost if you're going to that point.
I look at some of the constants we use, like 1 out of 10 times an operator is not, or an alarm is not going to be handled properly. We kind of say that across the board. Most companies I see, they use that. But in fact, during high intensity times, that factor is variable, and we see that in the presentation. It's variable on a number of instances, a number of conditions, and so that is the point that I'm trying to understand, whether we want to dig into it further or whether we're okay with 1 out of 10 and let's just continue.
I think that, so this is Camille, if you don't mind if my jumping in real quickly, because, what you're, I think, getting into is the challenge of the values that are being included in the quantitative risk analysis when you're looking at, when you're including human reliability into quantitative risk analysis. And I think that what you're realizing as you're seeing this is that right now the human reliability analysis doesn't really allow for what we would say is the interactions that happen well, there's two things. One, that much of those values are not based necessarily in the domains and on in current science, and people who love those data will tell you that. And two, there's not a mathematical mechanism in the human reliability analysis to allow for interactions to occur. That what is the probability of a human failure with an alarm if somebody is fatigued versus if they are not fatigued, if there's a good safety climate versus if there's a bad safety climate, or if they're fatigued in a bad safety climate versus not fatigued in a bad safety climate. And I think that's the challenge, and is that, so Ranjana and I are working on developing sort of what are those basic values for that quantitative risk assessment that you all need. And then we need to get people like my colleague Ron Boring in here to help us be able to develop methodologies for interactions in those domains, is my personal opinion or professional opinion and of that.
Thank you, Camille. Paulo, you had a comment?
Yeah, thank you, Angela. Dave, regarding your question that becomes a statement, I want to share a recent experience. We were working with a company, and we have, after some surveys and work with them, we had found that most of the people that tend to work extra hours didn't have pressure from co-workers, from their boss, from the management, and they have the pressure to make extra work, additional hours, and then get tired because himself. So an early finding could be that not necessarily just an fatigue risk management system such as those on APR is enough. Perhaps it's necessary to go deeper to try to find some additional that many people mention a lot of in the chat that are related with fatigue. The fatigue risk management is good and for sure will be very useful, but perhaps it's not enough because in certain cases there will be additional drivers that make people to become tired at their works.
That's a good comment because I've been an overachiever for quite a while. And I will admit that in my overachievement, sometimes I'm doing a lot of stuff and making myself tired that may not be related to what my company even places as a priority on me. So it's very. That's why I like the idea of having some independent tool. Because maybe if I'd had something where I could have tested myself and said, "Look, Angela, you're like really tired. You do need to quit working right now," versus, I can get one more thing done before I go to bed. I know it's 1 o'clock in the morning, but I can get one more thing done. So I really appreciate that, Paulo, because I can see myself in that. Luis, you have another comment?
Actually, it was not a comment, it was a request. I was going to ask Rahana if she could share the slide where the process when the person is under stress, rather than going from visual to motoring and then to it does a short circuit, go directly, ignore what he's looking at. And could you share that slide with us? Because I think this is exactly the point. I just wrote in the notes. It's a pity the colleagues of alarm group the 18.2 are not here, because alarm means reaction by an operator. And this is where we tend to sometimes claim too much credit, okay? So when we say, oh, you have enough time, you have no stress, how do you know? The guy have another life at home, and it may come from the home already under the stress. And then the first 5 minutes of work, he have an alarm. And the guy ignores completely what he's looking at and react, automatically. And my understanding that the reason that what they train pilots so thoroughly, so that if the situation comes, they react by, they have reflect that the automatic take control kind of thing. So this is really good stuff. So I wonder if you could share that slide for us.
So Luis, the presenters have allowed me to record the video, and I'm going to make that available.
All right. Thank you very much.
Okay.
And Luis, you're right. That was just to respond to Luis too. That was referenced in that BP slide, that safety moment slide. Because if I remember reading that correctly, the senior operator left the facility because he had something to take care of personally, and then when he left, it left the operator that was untrained, without backup, and also to run that board.
Exactly.
So yeah, you're spot on with that comment.
Exactly. I mean, when I hear our guest talking, I was thinking in my head, I was going alarm, 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 alarm. Sometimes we are taking too much credit for alarms. And anyway, in my opinion.
Yeah.
So thank you.
One other, we talked about different physical conditions, and it was just brought up about somebody getting a workplace distraction. Sometimes I have people on a site for weeks, they're out of town and they're away from their family. And so emotional stress starts to get into the way. Not that they're fighting with spouses, but that they haven't seen their kids in 2 months. Because there's not enough time to get on a plane and travel back home and then get back to the site in just a day or two. So I assume that emotional issues also increase potential stress and fatigue.
So Angela, yes. So the answer to that is yes. I personally haven't focused on emotional factors leading to fatigue or stress, but in one of our studies, we did find that emotional, fatigue was a big component or contributor to the feeling of fatigue by workers, and that was new to us. That workers were able to disclose that is what was, making them fatigued, and we have published that as well. So it definitely is a big issue. I think, like I said, when I started with this presentation, fatigue is a very complex, construct, and it has a lot of different origins, and it can manifest very differently in different individuals. So this clearly is a factor. We haven't studied it in the lab, but I think there is merit to, when you have your fatigue risk management systems, go beyond just work aspects, because slowly the line between, let's say, wellness and workplace safety or workplace ergonomics and safety is really merging. So you want to make sure that psychosocially your workers are healthy during the task, so that it doesn't creep out into their work performance as well.
Thank you. Any other questions, Murli?
Yeah, I was just reflecting on, Angela, what you said, and what we experience today with COVID and work from home and things like that. It's not just the people doing physical work, but if you look at people even in engineering roles, not being with the team that they work closely with does bring in the anxiety factor, right? And that does impact efficiencies, and when it impacts efficiency, it automatically leads to stress. So my question was, has that kind of a situation been taken into account or studied at all?
There is quite a lot of literature around psychosocial stress. Now with COVID, I think there are a lot of papers that are coming out right now and talking about workplace challenges and isolation. In fact, if you think about it, NASA has studied this really well, because they're supposed to work in highly critical environments, but remain isolated for months at a time, away from not just their loved ones or their general circle of friends, but also from Earth. And so it does make a big difference in team cognition. It makes an impact on their physiological responses. I haven't studied it, but I'm sure what you all are telling is there is clearly a need for systematic investigations, and we need to start doing those.